Hello. In this video, we are going to cover section 1.2, which is on classifying and storing data. Data consists of characteristics of people or things. We call these characteristics variables. Variables are not unknowns as in algebra. Characteristics are called variables because they have variability. These are things that vary throughout the data set. So for example, let's say that you were studying people. Okay, what would be an example of characteristics of people? Right, so you could have gender as a characteristic of a person, weight as a characteristic, height, ethnicity, even income, right, or where they were born, right? These are all characteristics. They're all things that are different from person to person, so they would all be variables, okay? Another example that's non-person related could be companies. So companies have characteristics, right? And those characteristics would be variables, right? So the headquarters are going to be different. They're going to vary from company to company. So that's going to be a variable. Revenue, sales, right? The principal product that they sell, right? Those are all going to be examples of characteristics of companies that are different from company to company. And so they're all variables. Data are grouped into collections. All right, so we would typically call a collection of data, we'd call that a data set. Sometimes we use the term sample. Sample is used when it implies that it's part of a bigger picture. The bigger picture is called the population. The population is the data set of everyone or everything with respect to the variable. Okay, so for example, if we were to look at the heights of students at a college, the sample would be the heights in a classroom. It's a small group of heights, okay? And then the population is everything. It's the heights of all of the students. Another example that you typically see for sample and population comes down to political polling, right? So let's say that we're interested in getting people's opinions on some political topic, right? So what we have is we have the population is all of the adults, all the voting adults, all right, in the country. That's everyone. Now, it would be very difficult to go through and poll everyone. It would be very difficult to go through and ask every single person in the entire country, every single adult in the entire country, what their opinion is on this political topic. So what we do instead is we go through and collect data on a sample. So we take a small subset. So let's say we take 2,000 people. So we go and we ask 2,000 people what their opinion is, okay? And then we use the result of that sample to be able to say something about the opinions of everyone, which is the population, all right? So the sample is the small thing, it's a subset. The population is the big thing, it's the everything. All right, so we break down variables into two types. We break them down into numerical and categorical. So numerical variables are quantities, all right? They're characteristics that are numbers, all right? Categorical variables are qualities, all right? They're characteristics that are words, okay? So eye color, for example. Okay, we do sometimes represent categorical variables with numbers, but we'll come back to that. So let's just look at an example because it'll be easier to understand an example, right? So here we've got a data set. The data set consists of variables. What are the variables? The variables are make, model, doors, weight, and head injury. All right, so the variables, those are the headings, okay, in our data set. And what we can do is we can go through and break down those variables into our two different types. All right, so think about it for a second based upon the definition on the previous slide. All right, what variables here do you think would be categorical and which variables would be numerical? Okay, so the make and model, notice those are words, and so we would consider those to be categorical variables. And then the doors, weight, and head injuries, those are all numbers, so we would consider those to be numerical variables. All right, so let's go back to the categorical variables as numbers thing. All right, this does occur sometimes, and when that happens, we call this coding. So coding is used when you only have two values for a variable, such as yes or no, or true or false. Okay, and so we can go through and we can look at this data set that we have here, and we have coding in this data set. We can go through and interpret that, the coding. Let's take a look at this. So what we've got is we've got a variable female and we've got a variable smoke. All right, and you notice we've got zeros and ones. When you see zeros and ones, that typically means you've got coding. Typically, I mean, you could have a numerical value where it's the results are either 0 or 1, but that's not typically the case. And so the ones in this case means true, the zeros means false. So we could go through, and if you look down this column, all right, wherever there's a 1, that means true. That means that the individual here, all right, what are we talking about here? We're talking about newborns, that the newborn is a female. All right, so we've got this newborn that's in this row is a female. This newborn is a female, another female, female, female. And then we've got 0, that's going to be false. So the opposite of being a female would be male. And so we have a row that's for male. Okay. And then let's look at our other variable here, smoke. All right. So in this case, 1 would mean that the parent smoked. Okay. Not the child, not the newborn. Would mean that the parent smoked, and then 0 would be false. Okay. So we can look down. So we've got the first newborn's mother did not smoke. The second one did. And then no, 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 and no. All right, so we only had 1 smoker. Okay. One thing that's interesting in the table here that's supposed to draw your attention is that the 1 smoker had a premature, the child was premature. All right, so that's supposed to be some relevant information that you can draw from looking at the table, whereas all of the children that were non-smokers, all right, had healthier baby weights. And I think it's supposed to be a coincidence that you had females for all the healthy children, healthy newborns, and then you had a male for the 1 premature child. So one of the neat things that you can do with coding is that you can go through and you can sum the values, and that will tell you how many true results there are. So if you were to go through and sum down this female column, you'd get 1 plus 0 plus 1 plus 1 plus 1 plus 1. That's 5. So that would tell us that there are 5 females in the data set. All right, and you could do the same thing for smoke. We could go through and we could just add down the column here, and so we can go through and that can tell us that there's one smoker, 1 mother smoked. All right, so that may not seem particularly useful in this case where the data table is pretty small, right? But if you had a data set that had thousands of entries and you were working in a spreadsheet, and you could just, with a punch of a button, you could say add up everything that's in this column, that can be very useful to be able to go through and do that. So that's one reason that you would go through and you'd use coding. All right, so storing data. Data is typically stored in a spreadsheet type format, which is what we've been looking at on the previous 2 pages, where each row represents an object or a person that's in the data set, and each column represents a variable. So here's another example of some data, right? And it's stored in a spreadsheet type format. We've got 4 variables in this case: the title, the rating, the runtime, and the critics rating. Okay, and then each row represents an object that we're interested in studying. That's part of our data set. Okay, and then, like we just went over, the columns represent the variables. Okay, and that's what I wrote below here. All right, another thing that we could do while we're looking at this is we could go through and determine what's categorical and what's numerical, right? So we could do another example of that. So take a look at that. What's categorical and what's numerical? All right. So the titles would be categorical variables, of course. The ratings would also be categorical variables. The runtime and the critics rating would be numerical variables. Where might we use coding if we wanted to use coding in this data set? What would be a variable that we could code? The rating, right? Because there's only 2 values, right? So whenever you get when you have only 2 values, that's a case where you could go through and use coding. And the way in which you'd use coding in that case is at the top here, instead of put rating, you would put rated G, and then you'd have 1 here, 1 here, 1 here, and then zeros for the rest. All right. So you want to take a column heading then in that case, and then be able to put ones where that column heading is true and zeros where that column heading is false. Okay. All right, I think that's it. Yep, and that's the last slide for this section. So that's section 1.2. Thank you for watching, and I'll see you next time. Bye-bye.